Good morning, students. Today we'll start topic number 6, duty and delta numericals and optimum utilization of irrigation water. So in the last class, I gave an assignment regarding this question. So in this class, we'll discuss about the answer. So this is the answer. So it was given area irrigated was 245 hectares. Discharge for Kharif crop was given as 0.5. Discharge for Rabi crop was given as 0.7. Discharge for hot weather crop was given as 1.2. Now, duty during the Kharif crop can be calculated by using the formula area irrigated divided by discharge. So area irrigated was given 245. Discharge for Kharif was 0.5. On dividing, we found the answer as 490 hectares per cubic. Duty during Rabi. So duty during Rabi, the answer is 350 hectares per cubic. Duty during hot weather is 204.16 hectares per cubic. You can note down this answer if you want to, but I will be sharing this slide with you. So the next topic is delta for certain crops. So the average values of deltas for certain crops are shown in the table given below. These values represent the total water requirement of the crops. The actual requirement of irrigation water may be less depending upon the useful rain. Moreover, these values represent the values on field, that is delta on field, which includes the evaporation and percolation losses. So, table 2.1 shows the average approximate values of delta for certain important crops in India. So, the crops and the delta values for those crops are shown in this table. You can have a look through it. Okay, so the next numerical is, if wheat requires about 7.5 centimeter of water after every 28 days and the base period for wheat is 140 days, we have to find out the value of delta for wheat. So we assume that the base period represents the crop period. So this can easily infer that the water is required at an average interval of 28 days, which has been given, and the total period being 140 days, which has also been given. So this means that base period divided by days, that is B by D is equal to 140 by 28, which gives the answer as 5, and 5 is the number of waterings that are required. So the depth of water required each time is 7.5 centimeter, which has also been given. So now when we find the total depth of water which will be required in 140 days, it is 5 into 7.5 centimeter. 5 is the number of waterings required and 7.5 is the depth of water required each time. So by multiplying these two values, we get the answer as 37.5 centimeters. So hence delta for wheat is found to be 37.5 centimeter. The next topic is optimum utilization of irrigation water. If a crop is sown and produced under absolutely identical conditions or similar conditions by using different amounts of water depths, the yield is found to vary. The yield increases with water, reaches a certain maximum value, and then it falls down, and it has been shown in figure 2.2 in our next slides. So the quantity of water at which the yield is maximum, it is known as optimum water depth. So therefore, optimum utilization of irrigation generally means getting maximum yield with any amount of water. The supplies of water to the various crops should be adjusted in such a way so as to get optimum benefit ratio, not only for the efficient use of available water and maximum yield, but also to prevent waterlogging of the land in question. So, to achieve economy in the use of water, it is necessary that the farmers be made acquainted, or rather be given the knowledge with the fact that only a certain fixed amount of water gives best results. More than that quantity as well, less than that quantity reduces the yield. So many cultivators still today feel that they can increase the crop yield by just using more and more water. Hence they try to supply more water to their fields by undue tapping at the outlets. This must be checked. So moreover, farmers should be encouraged to line their water courses, thereby saving at least 20% of the costly irrigation. So this is the figure or the diagram. or the diagram for yield versus water depth, you can see that the graph increases and it reaches a certain point. That point is known as maximum yield, and after that certain point, the value decreases. So the increased portion, the increased value is known as the optimum depth. The next topic is effective rainfall, denoted by capital R suffix E. So precipitation falling during the growing period of a crop that is available to meet the evapotranspiration needs of the crop is called as effective rainfall. It does not include precipitation lost through deep percolation below the root zone or the water lost as surface runoff. Average ratios applicable to effective rainfall are shown in table 2.4 in our next slide. This is the table which shows the average ratios applicable to effective rainfall with the headings average annual rainfall in centimeters and percent chance of occurrence of the rainfall. So this is your assignment for lecture number 10. I have given you two questions. The first question is write about the average duty values of certain crops and in tabular form. The second question is, if rice requires about 10 cm depth of water at an average interval of about 10 days, the crop period for rice is 120 days, you have to find out the delta for rice. The last date of submission is on or before 10th of September, which is Thursday. So now we'll go to a video. So that's all for today's class, today's lecture rather. Thank you.
When growing in substrate, you need to give the right amount of water and fertilizers at the right time. This is not an easy task. Water shortage will dry out your plants, but excessive watering will decrease oxygen levels in the substrate, causing poor root development. The sun has the most influence on the transpiration of the plant, but wind and outside humidity also affect this. When the sun begins to shine, plants will transpire and need irrigation. But when it's cloudy and humid, your plants will have different irrigation needs. So how can you be in control of the moisture level of the substrate? We offer a tool to put you in control of the moisture level. With our moisture balance module, irrigation is adjusted based on three factors: water evaporation, plant water use, and the water content of the substrate. Plant transpiration can be measured either using scales or moisture sensors and drain sensors. The collected data enables your system to control the moisture levels to perfectly meet the plant needs at any given moment. Your Priva system will ensure that your plants get the right amount of water and fertilizers at the right time to maintain a perfect moisture level. When the scales or sensors indicate a fast moisture level drop in the morning, the system knows that the plants are consuming water and will automatically start irrigation, perfectly timed and quantified. No more water stress and guttation. During the day, the system will ensure an optimal balance between water and oxygen with minimal drainage. And at the end of the day, it will make sure that irrigation is done in time to achieve the desired overnight dryout. Priva, increased production by optimal water dosing. you